Welcome back to Business Statistics 207. Up until this point, we've covered procedures for collecting data, determining data measurement level, and describing the data we've collected. In this series, we'll delve into describing data using numerical measures. Here are the key learning outcomes for Chapter 2. After this series, you should have a fundamental understanding of the difference between parameters and statistics, computing the mean, median, and mode, as well as interpreting measures of variation. You learned in Chapter 2 that frequency histograms are an effective way of converting quantitative data into useful information. The histogram provides a visual indication of where data are centered and how much spread there is in the data around the center. However, to fully describe a quantitative variable, we also need to compute measures of its center and spread. These measures can then be coupled with the histogram to give a clear picture of the variable's distribution. This section focuses on measures of the center of data, and the next section to introduce measures of the spread of data. Depending on whether we are working with a population or sample, a numerical measure is known as either a parameter or a statistic. Simply remember that parameters are computed from the entire population, whereas a statistic is a measure computed from a sample that has been selected from a population. There are three important measures of the center of a set of data. The first is the mean, or the average of the data. To find the mean, we sum the values and divide this sum by the number of data values. The population mean is represented by the Greek symbol mu. If the data constitute a sample rather than a population, the mean for the sample is computed similar to before, except this time we divide by the sample size, not the population size. The mean is the balance point for the data, so using the mean as a measure of the center generally makes sense. However, the mean does have a potential disadvantage. It can be affected by extreme values. In this case, we should turn our attention to a second measure called the median. The median is found by first arranging data in numerical order from smallest to largest. Data that are sorted in order are referred to as a data array. We use the median index to find the index point in the data set corresponding to the median value. Notice how the median is unperturbed by extreme values. In this example, we have 5 values, but it makes no difference if our largest value is 5 or 10. The median is equal to 3 in both instances. When computing the median using the median index, it's particularly important to round up to the next highest integer if the index point is not an integer. If it is an integer, the median is the average of the values at the index point and the index point plus 1. In this example, we have a data array where n is equal to 13. Using the median index, the result is 6.5. Since this is not an integer, we round up and the median is the value at the 7th position. In this case, the value is 12. Data in a population or a sample can be either symmetric or skewed, depending on how the data are distributed around the center. The median is particularly useful as a measure of the center when the data are highly skewed. In a perfectly symmetric distribution, the data are spread evenly around the center. In this case, the mean is equal to the median. The greater the difference between the mean and the median, the more skewed the distribution. Skewed data are not symmetric, and the mean may be greater than or less than the median. The mean is the most commonly used measure of central location, followed closely by the median. However, the mode is another measure that is occasionally used as a measure of central location. The mode is a value in a dataset that occurs most frequently. A dataset may have more than one mode if 2 or more values tie for the most frequently occurring value. It's important to understand what measure you are observing when it's reported. Generally, the mean is used unless extreme values exist. In this case, the median may be used. It's my personal preference to have both the mean and the median when possible. While the arithmetic mean is the most frequently used measure of central location, we can also compute a weighted mean by assigning different weights to each data value. One weighted mean example that you are probably very familiar with is your college grade point average, or GPA. At most schools, A equals 4 points, B equals 3 points, and so forth. Each course has a certain number of credits, usually 1 to 5. The credits are the weights. Your GPA is computed by summing the product of points earned in a course and the credits for the course, and then dividing this sum by the total number of credits earned. In some applications, we might wish to describe the location of the data in terms other than the center of the data. For example, prior to enrolling at your university, you took the SAT or the ACT test and received a percentile score in math and verbal skills. If you received word that your standardized exam score was at the 90th percentile, it means that you scored as high or higher than 90% of the other students who took the exam. The score at the 50th percentile would indicate that you were at the median, where at least 50% scored at or below and at least 50% scored at or above your score. We can also describe data in quartiles, which are those values that divide the data set into 4 equally sized groups. Here the median corresponds to the second quartile. Perhaps we'd like to determine the 60th percentile in an array of 19 values. We would rank order and use the percentile index to determine the location. Again, since the resulting value is not an integer, we round up to 12. This is the location at the 60th percentile, and the corresponding value with location 12 is 82. Likewise, we could also do the same method but with quartiles. The first quartile, which corresponds to the 25th percentile, is the value at position 5, which is 51. I should also mention that Excel may give you a different value than if you solve by hand using the index equation. This is fine, and either method is acceptable. However, Excel is the preferred method in this course. We can also graphically plot data in the form of a box and whisker plot, also known as a box plot. The box and whisker plot incorporates the median and the quartiles to graphically display quantitative data. It is also used to identify outliers that are usually small or large data values that lie mostly by themselves. Essentially, it is a graph that is composed of two parts, a box and the whiskers. The box is a width that ranges from the first quartile to the third quartile. A vertical line through the box is placed at the median. Limits are located at a value that is 1.5 times an interquartile range, below the first quartile and above the third quartile. The whiskers extend to the left to the lowest value within the limit and to the right to the highest value within the limits. One final note in this video, you need to be very aware of the level of data you are working with before computing numerical measures introduced in this chapter. A common mistake is to compute means on the nominal level data. Now that we know how to categorize data, use this chart to make sure you are applying the right method to describing the data. Go ahead and enter the following data into Excel and follow along. Now that we have the data into Excel, we can enter into a single column or within a couple rows and columns. Either way works unless you want to make a pivot table, in which case you should use a single column. I personally like to label the cells that I will use when I make a calculation, so I created the cells mean, median, and mode. To calculate the mean, simply type equals average, open parentheses, select the data, close parentheses, and click enter. Likewise for the median, we type equals median, open parentheses, select the data, close parentheses, enter. And finally, to compute the mode, highlight a few rows and type equals mode.mult. Again, select your data, close your parentheses, and press Ctrl Shift Enter to enter it as an array, returning multiple modes if there are any. In this case, we see we only have one mode, which is 19, same as the mean and the median. In this case, the mean, median, and mode are all equivalent, so the data is symmetrical. If you have phstat add-in, we can easily create a box and whisker plot. Simply open your add-ins, phstat, descriptive statistics, and select box plot. Go ahead and select your data range. First cell does not contain a label, and click OK. As you can see, here's our box plot and data sheet. phstat makes it easy. Alright, one final method that we could use to compute the mode is to simply create a pivot table. Do that again by clicking within the data, insert, pivot table, click OK to create a new sheet, drag our data to rows and values, again count, and you can build a histogram off this if you'd like. And as you can see, 19 is the most common number, so our mode is 19. Or you could also highlight the data and sort largest to smallest, and our mode would be at the top. Any values that had the same number would be multiple modes. Again, you can see that we don't have that in this case.